now with us Yifeng Song from Ryzen. He's the head of product management and has been with TaiyangNews events for a couple of times. So we're very happy to have Yifeng dialed in from China, although being very late, and present on Ryzen's work and products based on 200mm high power modules for various applications, which is also a very important topic, I believe. Yifeng, the floor is yours.
Okay, thank you very much, Michael, and thank you very much for the group to supply excellent.
Wait, Danny, we cannot hear you so well. Can you go closer to the mic?
How about now?
Now it's better. Huh?
Okay, sorry. I will close with the microphone. So can you see my presentation?
Yes. Go in presentation mode, please.
Okay. Well, okay. First of all, I want to thank for all of you that take the time in this webinar. It's excellent webinar, and it's Yifeng Song. I come from Ryzen Energy, and here I'm very happy to.
Danny, do you have a headphone? Do you have a headset with you?
Yes.
Yeah, now it's better, but I think so. But there's this modulation, so it's. Now it's better, right? But if you're very close, then it's good, like this.
Okay. I will do like this way. So I will start my presentation, and thanks for all of you to attend this excellent webinar. And it is Yifeng Song. I come from Ryzen Energy, and here I will take this chance to introduce my company, Ryzen Energy, and also our high power modules with 210mm wafers. Okay, first of all, I want to say that when we talk about Ryzen, I think everybody will have two marks of Ryzen. Firstly, Ryzen is a company that produced 210 modules with high power modules with the wafers. And another issue is that, okay, Ryzen is a company who produces heterojunction cells. Yes, it is true. But everybody, when we talking about the 210 modules, the module with the 210 wafers, okay, it's a very big cell, and it's a big wafer, big cell, so we can get a very big modules. Is it true? I will give you more introduction of this, because together with the technical approach in these years, especially from the 2018, the technical change is very fast. It's very fast. But anyway, you can also see the module power was increased very fast. I think from last 10 years, maybe only 5 watts, 10 watts, maybe no more than 20 watts increase per year. But if we see that from 2019 to now, every year module power was increased for about 100 watts. So it is a very great progress, technical progress in the PV industry. But everybody will consider, is it the final purpose to increase module power? I think it's not. It is not fully right, but we can say it's partially right, because at this moment nobody will consider about that if the module power is higher or not. What we consider or what we target is the LCOE. If this module power, this power module can decrease LCOE significantly, this is a good product, and this can be accepted on the market. If you only produce a high power module but without any improvement to lower the LCOE, it makes no sense, because you cannot make good values to the end customer. And this, and here I just show you that the different change in this year and how to reduce the LCOE. It's not
Danny, your slides are not really moving. We still see the intro slide.
How about now?
Yeah, now it works. Yeah.
Okay.
Can you go back? Can you show, maybe go one back? Actually, just show once again where you.
You mean this page, last page? Or?
Yeah, where you were before. Okay, sorry. Just
this is the last page. We're just talking about that LCOE is the core, not
okay.
Power. So next page, I just show you that what is the trend of in future. In future, the high power module is not final purpose, but the high power string. And because I think a moment ago there is an introduction presentation from the Trino colleagues, and he has already given very detailed information and introduction of what is a high power string. This is we have the same opinion of this point, that because in future, if we want to reduce the LCOE more, that the high power string is a future trend. And I think that a moment ago I also talking about that in the past time, we think that especially from the 2018 to 2020 or 2021, we can see there are really lots of technical approach. For example, the module, the wafer size from the M2 to G1 to M6 to M10 to G12, and also the bus bar will also change from the 5 bus bar to 9 bus bar, and also we can see there are 5 bus bar, 9 bus bar, 11 bus bar, 10 bus bar, 12 bus bar. And we can also see that from the technology, from the N-type PERC, from the HJT, from the to the also the top down and everything was combined together. So how to make judgment? What is the future trend? In our opinion, I think that if we mix them together, it will be very confused. So here I just to make a different different dimensions to describe this situation. We call this from the low dimensionality to the high dimensionality. And here I just to divide for several dimensionalities. Of course, if you are interested for this chart, you can also put more dimensionalities in this. Here I just put the bus bar numbers, and maybe now in the past time for the T1 modules we use the 5 bus bar. M2 we use 5 bus bar, and for the T1 we use 9 bus bar, and for T12 we use 12 bus bar. But maybe in the future, I think there should be the trend will be no bus bar of the modules. And in the future, and I think maybe the grid line, I mean the finger line, small thinner line, will also disappear. So this is the future trend. And from the low dimensionality to the high dimensionality. For the wafer size, it's also the same. I think the G12 is the final dimensions in the world. So when we're talking about this, every time I like to describe this with the semiconductor industry, because when we're talking about the TV industry and the semiconductor industry, we don't see that their technical are similar. What I want to see is that the G12, this wafer size is used in the semiconductor and lasts for more years. And for the PV industry, if we use the G12 wafers, it also can be a stable size for several years. And it will help the whole industry to focus their energy on how to improve the cell efficiency, to improve the module efficiency. That's all, not only to compare or compete with the wafer size and the cell size. It makes no sense for the whole industry. So that is also one reason why Ryzen, Trina, and all the other guys, other companies select D12 as their final wafer size for the new product. And another dimensionality is the cell type. For example, here I just put the PERC plus SE, the TOPCon, the Polo, and HJT. And it's significantly, from our opinion, we think that in future, HJT technology is the future trend. So from anyway, in one word, from the rising energy, we think we can separate different technicals as different dimensionality and make this kind of analysis. But for rising, we think the wafer size, the J12, is the final size, and the HJT is the future trend for the cell technology. And this is the technology roadmap of Ryzen. And in the future, we will also combine the HJT with the G12 and for the new product. And here I will show you our product roadmap. And here I just put the two circles here. One is N-type PERC, and another is N-type Heterojunction technology. So all these two technologies will be based on the 210 wafer workplate. And here is our main products for our P-type PERC. And all these modules, I think the highest module module power is the 660. So this type modules, you can see the samples in the SNEC this year, and we are also welcome to that you can visit us at SNEC. So at N1, the whole N1, and the output number is 515. So all these products is from the small modules to the big modules, and every module we use for the different scenario. For example, the 400 modules, I say here the maximum module output is 410 watts, and the normal, the average module power is 405. So far, this module already in the production and used for the residential applications. And the 510 watt modules, and this type we are used for the industry and commercial application scenarios. And another 3 are used for the centralized ground power plant applications. And from us, I think all these products have significant advantages in the current market. And another type is our heterojunction series. And so far, these 4 products are our main products. And you can also check these products in our booth. And what I want to mention is the last modules we call the 630 watts with the heterojunction cell. I think this is the first heterojunction modules with the 210 wafers in the world. This is the samples, but we can also check the modules in our booth. And all these modules we use advanced technologies. And yesterday I also attended this webinar, and I also see that other companies they also introduce some of them. So here I will not give a very detailed introduction of these technologies, such as the non-destructive slice and the high density encapsulation. So I think these are advanced technologies, and we already use them for our product to ensure our quality and reliability. And another issue is that last time also some customer also asked me what about the container loading of your modules with the 210 wafers, because at the beginning when the 210 modules was born, there are lots of concerns from the market to say, "Hi, your module is too big. How can we load it in the container?" But here I just want to say, don't worry about that. This issue has already been solved, and you can see the tables in my presentation, and compared with the 166 millimeter from the 166, this module type and the transportation cost will be lower because we can load it more power per container. by the current packaging and the loading method of our tutor modules. So this issue has already been solved at the beginning when we, and of course, maybe this too much work to say like this. In one word, I can say this module has already been shipped out for more than 100 megawatts already. So there's no problem for the loading and the shipment. And another issue is that everybody will say, okay, you use the two wafers and the cells, and I know that the current is much bigger. It's almost 18 ampere. How about the risk of the hotspot? The high current will cause the hotspot. It's very much risk. Is it true? If you are interested in that, I can give you more introduction for this. Please check the presentation here. And when we're talking about hotspot, there are two issues we need to consider. First, we need to check the current, but the current is not the module current. I mean the output current. We need to check the string current. As you know, so far all the modules were produced with the half-path technology, and in every string here, you can see that the up half string, half path, and the bottom half path. These two parts are a parallel connection, but in every string, the current is only half of the total current. So it is only the 9.2 ampere. How about this this value? This value is almost similar or the same as the original 156.75, our original full cell module. Is there any big problem in the past time for this string current? No, there's no. And another issue, if we want to talk about the hotspots, there's another issue is that the cell quantity is the key point, because we need to check how much cells was connected per cell strings. Here we also make some tests, because you know, for our 600 watt modules, there are only 60 cells per string. So it means that per delt there are only 20. But for the other modules, if even the cell size is smaller, but for the if we use 72 cells, and the current, the power added on the filler cells will also be higher. So from this presentation, we make the evaluation, and we also make the actual test. And the future modules with the less cells quantities have the lowest temperature when there is a hotspot happen, or maybe we can say there is a shadow on the cell happen. So here, what I want to point out is that if we want to talk about current, it is not the current of the module output, but the string current. And for the module size, for the hotspots, if we want to talk about the cell size, this is not decided by the cell size, but the cell quantity per cell string. And another issue is the handling. And there are also some concern in the market to see that your modules is very big. It's very big. It's more than one G1 cells, more than M10 cells. How can we handle it? Is it true? Firstly, I think that nobody will handle the modules only from the corners. They will to take in the middle, in the every place. Here, I just marked here with the 30 degree. So this is really a good way. Is there any friction for handling? I don't think so. Here I also show some photos here for the handling. This is the real installation scenario, and I just take photos to show that there's no any problem for handling the two modules. And this is the maturing ecosystem. I think a moment ago in the presentation from Trina, they also gave a very detailed introduction. But here I just want to see that this is a maturing ecosystem. It is welcome that everybody can join this. And so far, this alliance already included different companies from the upstream to the downstream, to the downstreams. And at the beginning, I think there are only 39 members of this alliance, but so far I think only 9 months passed. There are already more than so far there are already more than 70 members in this alliance. But this alliance is very open. This alliance is very open. We welcome, because in this alliance, please forget which cell size you used. What we want to do is that how to decrease the LCOE and how to give the most values to the final customer, the whole PV system, not only for others. So I think this is really good. And I think there is a very nice issue is that in the last year, I think everybody, if you work for the PV system or the designer or you are the owner, you will meet one issue. For example, if you use 450 watt modules, you can buy from different companies. But you will find that from different companies, the module size is totally different. It's totally different. But so far, for the for the 600 watt lines and for the modules you produce with the 210 wafers, we have already align all the module size. Align all the module size. For example, here I started to see. You can see the photo. You can see the plantation from the left. It's the difference of the module length, and the right one is the different module wise. But only the 210 modules we have already uniform. It means that if you buy these modules from Trina or from Ryzen or maybe from CSI, you can also get the same size, same module size, same the module length, and the same the module width. It will be benefit for everything. For us, it's a benefit for the material supplement and for the cell module production. And for the downstreams, it's a very benefit to the PV system designer and the installation, and also benefit for the PV system maintenance. So it is a really good issue for this alliance. I think it's the most contribution to the whole PV industry. Okay, here is the capacity of this product in Ryzen. So far, yesterday, there is an introduction from January, and there are also the data of this. I feel this right. In this year, our module capacity is about 280, 200, no, 200, sorry, is a 28 gigawatt, and for the cell is a 20 gigawatt. So here we have several production base, and mostly is located in China, and there is overseas manufacturer base is located in Malaysia. But this basement will be start, I think, will be at Q4 this year. For others, already start production. And for our 210 series modules, and the capacity will occupy more than 75 of the whole capacity. Okay, so talking about the full scenario, here is let's see our three main types. First used for the residential rooftop, another one used the INC rooftop, and the last one is will be used for the centralized ground power plant. And here, just some introduction of the module size and the weight. So here I just want to talking about our residential modules here, the Titan S. For this product, you can mention that you can check that here is the module size. The length is only 1,754 millimeter, and the width is 1096. And because before we develop this product, we also make a very detailed market investigation. Because in some area in the country, especially in Australia and in Europe, because the complicated roof situation because different shape. So there is a requirement for the module size that no more than 1,800 millimeter in length and no more than 1,100 millimeter at width. So that is the reason we designed these modules. And here is our first product for the Twitter modules, and this is used in the INC rooftop in the Malaysia, and about 30 kilowatts. And from the right tables, we can also see the benefit of this project compared with other products. And here is the analysis for the Titan 500 modules compared with the other modules. But how about the big power plant? How about our 550 watt modules compared with other products? And I think last time I also mentioned that the best issue is not a high power module, but the high stream power. So here I just want to see that we just analyze the fixed bracket and other things. So here is some detail how to say calculation. I will not give very detailed introduction. If you are interested, you can ask our marketing department get this presentation for review. And here I just to make some briefly introduction of this. But anyway, because we have the higher stream power, and we can save the land use. And here we can also save the steel rail by 4% compared with other products. And here is also the foundation saved. And here is the tracker. The tracking is the 1P tracking, and compared with other products, we can also can increase power capacity for each tracker because we can connect the most modules in the string. And here is the 600 watt modules. And I think the analysis is similar because of the high stream power, we can put more power, more modules in the per inverter, per string. And this is also can save the land using. And here is about the pile foundation saving. And here is the tracking and analysis. Also the can increase the power capacity. But anyway, here I just want to put more words on this point. For example, because so far everybody will know so far there are two main products in the PV market in this period. One is the module with the 210, and another one is with the 182. So I think that compared with the G1 and maybe compared with 166. The 182 cell modules and the 210 modules are also good, are both good modules compared with the past, because both of them can decrease the BOS and decrease SOE significantly. But so far we can also see that in some presentations from the different companies, they will have a different conclusion and the results. The company who produced 182 will say, okay, the 182 is the best. Blah blah, and for the and they also show their presentation like this result. And for the companies like Ryzen, when we produced because our main product is the 210 modules, so we will also have our analysis to see that the 210 modules have the best performance on the SOE and both. But for the customer or maybe for the installer, I think they will be confused about this. Who is right? Who said is right? But from my opinion, I think both products are good products. The both and SOE are related with different system design scheme, and this result will vary with different system design. You cannot use all the configuration of 182 to calculate the modules to change, and you cannot also do in a contrary way. I mean that you use all the configuration of Twitter to calculate the modules to 182. But anyway, uh, we can only see is that both 182 and the Twitter modules can reduce the Bose and series compared with modules of smaller size like G1 and M6. But 210 series products are still the ones that can reduce the Bose and LCE most because the Twitter modules is the trend. That's the one word can see that this is the trend. So here just some actual project with the Twitter modules. Here is used in the Poland about 50 megawatt. And here is 30 kilowatts that show you in the past in previous presentation. And also this is rooftop market in the Malaysia about 30 kilowatts. And here is in China about 1 megawatt in the Zhejiang Lishui, also a rooftop, not residential, it's a C&I rooftop project are already used. Okay, so further a very briefly introduction of Ryzen. And Ryzen was founded at 1986, but we focus on the TV industry from the 2002. And 2010, our company have the GM listing and we come to be a public company. And 2016, and our company come to be the tier one group. And in the 2019, I think there are two issues. One issue is that we produced the first Twitter modules in the world and announced. And another issue is that we start our Heterojunction module production at that year. And in 2010, we have the modules which the output is more than 600 watts. And our HJT modules are also ranked #1 for the annual shipment in the world in the 2020. And this is our many business in our company. We produce, of course, we produce cell, actuate modules, and other some materials such as UVA, ribbon, and the junction box. And we also have the EPC company to do some project. And also we have the energy storage solution company and that produce the the battery and energy storage to supply the whole energy management solution. And here is the whole globally distributions and the branches. I see the globally branches and many manufacturers are located in China and Malaysia, and all the other places are our sales office, sales service center. Okay, that's all. Thank you for everyone for listening. And Michael, I hand the microphone to you.
Thanks, Danny. Miraculously, your microphone got better during the presentation, so that was good. Just a few questions. I think that's probably, could talk 2 hours. You have shared so much, but as you said, I think people can get probably in touch with your marketing people. But a few questions from my side. So you showed actually the products you will present at SNEC, and I think the biggest product you showed for your HJT products was a 630 watt module, which had a 22% efficiency, and then you showed a 660 watt from PERC. Why did you choose these different sizes actually? What was the reason?
So what do you mean the different sizes? The size?
Yeah, I think so. Power ratings. I think so. Why do you have a PERC product with a higher power rating, which was 660, than the HJT product, which has 630, although the efficiency for HJT is better? So what's the reason for this?
There's no reason, just to create some samples. For example, the Heterojunction module we show here is 630 watts, right? The cells we use is 60. We can also produce modules with 60-60 cells, but output will be even higher than the 60-60. It is just a sample issue, not any other issues.
Okay, now I understand.
But the module size is totally the same.
Okay, you keep the module size anyway because you have standardized it, huh? So
yes,
that was the idea, as I understand. Huh?
Yes, you're right.
Okay, and what about actually, so in terms of general about HJT, because you said already, you pointed in one of your last slides that you already started mass production in 2019 for HJT. You have this 2.5 gigawatt plant, and you said in 2020 you were the largest supplier of HJT modules. So can you give us a little bit more background on how HJT is doing at the moment? So
yes, of course. You know, for the heterojunction module production, so far I think there are lots of companies in China that produce the heterojunction cell, but there's not too many companies produce the heterojunction modules, because there is one issue: the heterojunction cell, all the process. The temperature is lower. It's no more than 200 centigrade. It's not like TOPCon, not like the PERC. So it means that in the module soldering process, the soldering temperature must be controlled very carefully. If the temperature is very higher, it will damage the cell. But if the temperature is very low, the soldering will be bad. The cold soldering will happen. So it means that if you use the heterojunction cell, you have to pay more attention on the module production. I think there's not too many companies in China that can produce with the, I can say, not the smart wire technology, but we can see the very traditional, conventional soldering technology for the heterojunction production. There's not too many companies do like that. But Ryzen is one of that. And last year, compared with the shipments of our P-type PERC module, the heterojunction modules are very less volume shipped out, only 70 megawatts the whole year. But anyway, even this only no more than 100 megawatts for the shipment of HJT modules, it is still the top one in the world.
Okay, and then what's the plan for this year?
Yeah, for the plan, I think we will focus on the next step, because so far we also have the heterojunction cell production by ourselves, but this is with the T1 cells. So our major products in this year still be this one, but we also focus on the next generation with heterojunction plus the 210 wafers, like what we show. But so far, these are only the samples. The first samples, not mass production. But I think in the future, this will be the trend. We will do like this. But for the heterojunction, there's one issue, because the big wafer is not problem. The problem is that in the meantime, I mean that when we want to use the big wafers for the heterojunction, the problem is that how to use it when the wafer come to be thinner and thinner. Because you know, so far when we use the G1 wafers, our thickness of the heterojunction is only 150 micrometer. But if we use this for the 210 size, and I think there will be a very challenge for the wafer transportation and in the some process. So we need to solve that. So big cell is not a problem. The problem is that how to make it thinner, because it will decrease the cost much.
Okay, very interesting. Okay, thanks. If you have maybe, I think you wanted to leave soon, but if you have maybe 2-3 minutes, I think there are some more questions. If you could maybe handle that, Danny, that would be super nice. And
no problem.
I think so. Everyone, who needs the presentations, we will share. As usual, I think at TaiyangNews we only have the we have only the recordings on our YouTube channel, but for the company, if you want to really have the presentations, you can address the companies and send them an inquiry. We will share the emails later to all of you in an email. Okay, so thanks a lot, Danny. That was insightful.
Okay, thank you very much, Michael.
Thanks so much. Have a nice evening. Ciao.
Thank you. Bye.